Hi, this is Mrs. Often, and we're here today to discuss exponential expressions and equations. Just as a reminder to you, these exponential expressions will take the form of b to the x power, where b is the base and x is the exponents. And this will be introducing a new number, the number e. This is a transcendental number, a special type of irrational number, like pi. E is approximately equal to 2.71828, and it's a special button on your calculator. You'll see a button that says e to the x power. Okay, so the first thing that we want to be able to do is to evaluate exponential expressions, and I'll be doing this using my calculator. You do want to remember to use the order of operations. That means that you evaluate the exponents first and then do multiplication. So I'll do 3 to the 2.1 power, to the 2.1 power, and then after that I'm going to multiply by 2. So I get my final answer using a calculator of 20.09. Again, you may have noticed my hesitation there. That's because I was looking for the correct button on my calculator. Every calculator is different, so it's a good idea to become familiar with yours. It turns out that this button has a button called y to the x power. On some calculators, it's going to be a little caret button. Here, I'm using that special number e. If you can't find it on your calculator, it is okay to substitute that value, 2.71828. But I'd prefer that you know how to use the e to the x button on your calculator, so please locate that now. On my calculator, it's the second function on the key that says ln. So again, I'm going to evaluate 3 to the 0.01, multiply by -3, and then subtract 1. And I get, for a final answer, -4.030. Okay, so again, this is a good opportunity to become familiar with your calculator. I encourage you to practice this a few times until you're good at doing it quickly and you know where those buttons are on your calculator. One property that is very important for exponential expressions is the one-to-one property. The one-to-one property lets us isolate the exponential expression and then turn that other side of the equation into the same base raised to a power. So what I'm going to do is do all of my regular algebra steps to isolate this exponential expression. Then I'm going to try and turn this side of the equation into 5 to some power. So I'll start by subtracting 1 on both sides. That's going to give me 2 times 5 to the x minus 1 equals 250. I'm going to leave that x minus 1 in parentheses. I'll divide both sides by 2. Now I have 5 to the x minus 1 power equals 125. At this point, I'm going to say to myself, 125, is that 5 to some power? Now, if you are not sure, a great way of figuring this out is just repeatedly divide 125 by 5 until you get to the number 1. On a calculator or by hand, you'll see that you can divide 125 by 5 3 times. So that means that I can rewrite 5 to the x minus 1 is equal to 5 to the third power. The one-to-one property tells me if these expressions are equal to each other, well, it's because the exponents are equal. So now I have a really easy algebra equation to solve. X minus 1 equals 3. And so x is equal to 4. So our final answer here is that x equals 4. I can substitute this in. 4 minus 1 is 3. 5 to the third is 125 times 2 is 250 plus 1 gives me that answer of 251. So that is the one-to-one property. Here's another example of solving with the one-to-one property. Same approach that we're going to take here. I want to get my exponential expression all by itself. What do I need to do this? Well, first I need to eliminate 8. So I'll subtract 8 from both sides. I get -3 times 2 to the x power equals -48. Then I'll divide both sides by -3. -48 divided by -3 is 16. And 16 is 2 to the 4th power. Since the exponents need to be equal, that's the one-to-one property tells me, my answer must be x equals 4. Okay, so again, looking over here, 2 to the 4th is 16 times -3 is going to be -48. I have 8 minus 48, and that is -40. Okay, at this point, you might want to pause the video and copy down these two formulas for compound interest. These are really important formulas that you want to know about, because if you put money in a savings account, this is the formula that the bank is using. If you take out money for a loan, it turns out they use an even more complicated formula, which I will not be teaching at this time. But it still looks kind of similar to this one. First one is periodic compounding. This is when you compound monthly, quarterly, even yearly. We use this formula. In this formula, P is the principal, R is the rate. That's expressed as a decimal. So 5% rate is going to be like 0.05. T is the time in years, and N is the number of compounding periods in a single year. So if they say quarterly, then that N value is going to be 4. If they say monthly, it's going to be 12. We also have a formula for continuous compounding. I call this the shampoo formula because it's PERT. So P times e to the RT. E is that number again, 2.71828. R is still our rate expressed as a decimal, and T is the time in years. Now, continuous compounding doesn't really happen in the real world. We can compound daily or even 2 or 3 times a day, but we can't compound continually. This is a nice formula for getting the upper limit of what you could earn in interest. So if you have only $5,000 and you need to turn that into $20,000 by next year, well, continuous compounding can tell you about what sort of rate you would need to get. Okay, so those are your formulas, and we're going to do one example problem with this. So here's our compound interest formula, and I've underlined the critical parts here. $5,000 is placed in an account that has a rate of 5% and compounds quarterly. How much money is in that account after 4 years? I would love to get a rate of 5%. It's not happening right now, sadly, but let's say you could. Well, your principal is $5,000. Your rate is 0.05. Since this is quarterly, there's 4 quarters in a year, so N is 4, and T is 4 as well. I'm going to work through as much as I can fit of the formula on this page, just so you can see it all, but we start out by substituting everything we know. So notice I'm using that rate as a decimal, divided by N, and here's N times T. So I'll use my calculator. and divide 0.05 divided by 4 and add that to 1, I get 1.0125. Outside, I need to multiply those numerals in the exponent. 4 times 4 is 16. So I'm going to get, for the amount in the account, 5,000 times 1.0125 to the 16th power. Be sure you raise 1.0125 to the 16th power before multiplying by 5,000. If you do the multiplication and then the exponentiation, yes, all your dreams will come true. It's like you've won Powerball, but it's not going to be an accurate representation of how much is in the account. So again, on my calculator, I'm going to use the Y to the X button. And it turns out that this does get a little bit bigger. It's 1.2199. And, you know, the bank is going to be carrying its operations out to 3 or 4 or even 10 decimal places. So you should also be carrying your operations out to 5 or 6 or at least 4 decimal places. So I'm going to multiply 5,000 times 1.2199, and I'm going to get that I have over $6,000, almost $6,100, 6099.50. Okay, remember we're reporting in dollars and cents, so you don't want to put 6099.5, it's 0.50. So that's the compound interest formula. We did use this formula because it didn't tell us we were compounding continuously. The other formula is easier, but only good for compounding continuously. And that's your introduction to exponential equations and expressions. Thanks.